These are your notes for lesson 4.3, solving inequalities using multiplication or division. Using your guided notes here, says when you multiply or divide each side of an inequality by the same positive number, the inequality remains true. And that's what we're going to look at in example number 1 and example number 2. So example number 1, you have x divided by 5 is greater than or equal to negative 3. So again, idea of solving this inequality would be to get the x all by itself. And on the same side of if we draw a line straight down through the symbol there, we can see with the x is 5. To get rid of things, we're doing the inverse, we're doing the opposite. So the 5 is dividing the x, and the opposite of dividing by 5 is to multiply by 5. So I'm going to write times 5 beside that. And whatever I do to one side of that symbol, I have to do the same thing to the other. So on the right side of the greater than or equal to sign, I'm also going to write times 5. So my divide by 5 and my times 5 are going to cancel each other out. Because if x was, let's say x was 10, and you did 10 divided by 5, that would be 2. And if you take that answer and multiply by 5, you would be back to 10. So they're just offsetting each other. You're always going to be back to x. So the 5's cancel. X is now by itself, which is what we want. Bring down our symbol here, our sign, greater than or equal to. Do the math on the right side. Negative 3 times positive 5 is negative 15. So that's the answer to solving that inequality. So again, it remains true if we multiply or divide both sides by a positive number. Looking at example number 2 now, we have 6x is greater than negative 18. So again, same process here. We're trying to get the x all by itself. On the same side as the x is the 6. So to get rid of it, we have to figure out what is it doing, and we're going to do the opposite. So the opposite, we see that the 6 next to the x, we know that means multiplication. And the opposite of multiplying by 6 is to divide by 6. So drawing a line underneath, making a fraction. All fraction problems are division. So in green there, that means divide by 6. And if I divide the left side by 6, I have to divide the right side by 6. The 6's will cancel each other out here. 6 divided by 6 is 1. And 1 times the x will give us x. Bring down our greater than sign. Do the math on the right side. Negative 18 divided by 6 would be negative 3. So the answer to that inequality, the solution to that inequality would be x has to be greater than negative 3. Now, when you multiply or divide each side of an inequality by the same negative number, the direction of the inequality symbol must be reversed for the inequality to remain true. So in that blank should be reversed. Okay, so in the example 1 and 2, we multiplied or divided both sides by a positive number. So when we did that, it remained true. But if you multiply or divide both sides by a negative, you have to reverse the sign for it to remain true. So if we look at example 3 here, we have negative 3z is greater than negative 4.5. So again, we follow the same process. We want to get rid of the negative 3 to get the z by itself, and it is multiplying. That's what a number next to a variable means. The operation is going on as multiplication. So the opposite of multiplying by negative 3 is to divide by negative 3. Okay? And if I divide the left by negative 3, I also have to divide the right side by negative 3. So negative 3 divided by negative 3 is positive 1, and 1 times z is z. And on the other side, negative 4.5 divided by negative 3 is positive 1.5. A negative divided by a negative is a positive. Now, the sign. Let's say you don't reverse the sign. You leave it as a greater than sign. So that means you're saying that anything bigger than 1.5 would make this inequality true. So let's take a number greater than 1.5. Let's take 2. So if I have negative 3 and I replace the z with positive 2, so what positive 2 is greater than 1.5, so I do negative 3 times 2, and that has to be greater than negative 4.5. Negative 4.5. So now I do this math. Negative 3 times positive 2 is negative 6, is greater than negative 4.5. So you would have to ask yourself, is that true or is that false? Is negative 6 greater than negative 4.5? And the answer is false. And we would be able to see that on a number line. Here's 0. This would be negative 1, negative 2, negative 3, 4, negative 5, and negative 6. Remember, on a number line, whichever number's on the right is always the biggest number. So here's negative 4.5. Negative 4.5 would be right there. And negative 6 would be right there. So the green dot representing negative 4.5 is on the right of the orange dot at negative 6. So that means it's larger. So that sign, so it's a false statement. So what we have to do is, since we divided both sides by a negative right here, this operation right here, we divided both sides by a negative. Since we did that, that means that we have to flip the sign around. So our greater than sign will become a less than sign. So now, if I picked a number that was less than 1.5, any number, as long as it's less than 1.5, then this statement will be true. So negative 3 times, I'm going to use 0. 0 is less than 1.5. And I go back to the original inequality. So I have a greater than sign in there, and negative 4.5. So again, I'm going back to the original inequality, replacing it with 0 for my answer, saying that z has to be less than 1.5. So I get 0 is greater than negative 4.5. True or false? Again, if you think about your number line, here is 0. Negatives are always to the left of 0. So clearly the 0 is to the right, so it's the larger number. So that's a true statement. So we have another example here, example number 4. You notice that I have a negative sign with the c over 9. Remember, negative signs can go any of 3 places. It can go at the top with the numerator, so it can be negative c over 9. It can be right next to the fraction bar like they have it there. Fix that c. Or it can go with the denominator, in this case 9. And that would be the most sense. So when I rewrite this problem, I'm going to put the negative sign with the 9. Again, it's the entire fraction that's negative, but I can assign that negative sign with the numerator, the denominator, or right next to the fraction bar. So I get c over negative 9 is less than or equal to negative 4. Again, goal there is to get the c all by itself. To do that, I need to get rid of the negative 9. It is dividing the c. The opposite of dividing by negative 9 is to multiply by negative 9. And if I multiply the left side by negative 9, I have to do the exact same thing to the other side. So the negative 9s cancel. They're opposites. They cancel each other out, which would leave us with c. On the right side, I have negative 4 times negative 9, which is positive 36. Negative times a negative is a positive. And as you can see, I multiplied both sides by a negative. Therefore, I have to flip the sign. So my less than or equal to sign is going to become a greater than or equal to sign. So my answer for the solutions to that inequality is that c has to be greater than or equal to 36. So on the back of your guided notes, you've got some problems to try on your own. Again, it's just follow. These will be just like examples 1 and 2 in the notes, and 3 and 4 will be just like examples 3 and 4 in your notes. Show all of your work just like I displayed in the notes, and then answer this sign at the end, and we'll go over those in class.